Good morning everyone. I hope you are all doing well. My name is Dr. Amar Kumar De and I am excited to welcome you to today's lecture titled Pre-emphasis and De-emphasis in FM for the course Fundamental of Communication System and its Application. It's exciting to see so many of you joining us from different corners of the world. First and foremost, I want to extend a warm thanks for taking the time to be a part of this session. So, without further delay, let's move on to the topic titled Pre-emphasis and De-emphasis in FM. Before moving ahead, here's a quick overview of today's lecture titled Pre-emphasis and De-emphasis in FM. Today, we delve into the techniques of pre-emphasis and de-emphasis in FM broadcasting and communication system. These methods are pivotal in enhancing signal quality and maintaining audio fidelity during transmission. We begin with a look at their historical context. Pre-emphasis, our next topic, involves boosting the higher frequency components of the audio signal before modulation. Moving on to its implementation, pre-emphasis employs a high pass filter with a specific frequency response curve. The advantages of pre-emphasis will be discussed. Then we will talk about the applications of pre-emphasis. Shifting gears to the de-emphasis, the complementary process attenuate high frequency in the received FM signal to restore the original audio frequency response. After that, we will take implementations of de-emphasis. It is implemented using a low pass filter with a frequency response curve that complement the pre-emphasis curve, ensuring fidelity in audio signal reproduction. Then the benefits of de-emphasis will be covered. It's restore the original audio characteristic after transmission. We will focus on the applications of de-emphasis. It's find crucial applications in FM receivers, consumer electronics and broadcasting system, ensuring high quality audio response across various listening environment. Then we will conclude with a brief summary. Now, before diving into the topic, let's have a brief discussion on FM and its challenges. Let's begin with the overview of frequency modulation, FM. What is frequency modulation? Frequency modulation is a method of encoding information onto a carrier wave by varying its frequency in accordance with the amplitude of modulating signal. Unlike amplitude modulation, AM, which varies the amplitude of the carrier wave, FM changes the frequency. The modulation technique is widely used due to its resilience against amplitude variations and its ability to deliver clear audio signal over long distances. FM is extensively employed in applications like broadcasting, telecommunications. It also finds its application in broadcast television audio. However, FM transmission face inherent challenges that affects signal fidelity and reception quality. One of the primary challenge is maintaining signal fidelity throughout transmission. Signal fidelity refers to the accuracy with which the received signal responds to the original signal without distortion or degradation. Any alteration to the frequency characteristic during transmission can leads to a loss of fidelity, affecting the quality of the audio signal received by the listener. Additionally, FM signals are susceptible to various forms of interferences, including atmospheric noise, electrical noise and man-made interferences from other radio source. This noise can disrupt the clarity and intelligibility of the audio signal, posing significant challenges in achieving reliable communication and broadcasting. To address this challenge, engineers has developed specific techniques such as pre-emphasis and de-emphasis. Pre-emphasis is a method where high frequency of the audio signals are boosted before modulation. This technique is designed to compensate for the inherent noise characteristic of transmission channel, effectively improve the signal to noise ratio, abbreviated as SNR, and enhancing overall fidelity. Whereas the de-emphasis on the other hand is complementary process that attenuates the high frequency in the received FM signal to restore the original frequency response. So, by applying de-emphasis during reception, engineers can assure that the audio received by the listener accurately reflects the intended sound quality of the broadcast, minimizing the impact of noise interferences. So, in conclusion, while frequency modulation offers superior audio quality and resilience compared to amplitude modulation, it faces challenges related to signal fidelity and noise interferences. Engineers mitigate these challenges through innovation techniques like pre-emphasis and de-emphasis, which play a crucial role in maintaining high quality audio transmission in FM broadcast and communication system. These techniques not only enhance audio clarity, but also ensure reliable and intelligible reception across various listening environment, reinforcing FM's position as a perfect choice for communication and broadcast applications. Now, as we have a basic knowledge of pre-emphasis, let us discuss the need of pre-emphasis. So, why pre-emphasis is needed? Pre-emphasis is a critical technique in frequency modulation that addresses the challenges of noise interferences during signal transmissions. In FM, the amplitude of the modulating signal is directly affected by the frequency deviations of the carrier wave. However, the higher frequencies are more susceptible to attenuations and noise interferences during transmission. So, to encounter this, engineers apply pre-emphasis, which involves boosting higher frequencies of audio signal before modulation. By increasing the amplitude of the high frequency, pre-emphasis ensures that the component of the signals that are transmitted with greater power relative to that of the lower frequency. This adjustment effectively improves the signal to noise ratio during transmission, ensuring the overall fidelity and clarity of received audio signal. Consequently, listeners experience reduced noise interferences and enjoy clear audio quality, making pre-emphasis a fundamental technique in FM broadcasting and communication system. Now, it is time to discuss some of the interesting historical facts related to the development of the pre-emphasis technique. The concepts of pre-emphasis emerges alongside the development of FM broadcasting in early 20th century. One significant historical milestone was its integration to commercial broadcasting standards during mid 20th century in United States. For example, the Federal Communication Commission FCC mandate the use of pre-emphasis in FM broadcasting system to ensure uniformity and improved audio quality across radio station. This regulatory requirement underscores the importance of pre-emphasis in standardizing FM transmission and enhance the listening experience for millions of radio listeners around the worldwide. A compiling historical note relates to pre-emphasis involves its role in improvement of FM stereo broadcasting. In 1960s, stereo FM broadcasting gained popularity. Engineers faced challenges in maintaining high fidelity audio across both channels. Pre-emphasis play a crucial role in optimizing stereo separation and audio clarity by enhancing the transmission of high frequency essential for stereo imaging. This technological advancement not only revolutionized the FM broadcasting industry, but also contributed to the widespread adoption of FM stereo as a preferred format for high quality audio transmission. So, in conclusion, pre-emphasis is essential in FM communication system for mitigating noise interferences and improving signal fidelity. Now, with this fundamental knowledge of pre-emphasis and de-emphasis technique, let us dive deeper and try to understand its mathematical basis. So, pre-emphasis is a signal processing technique adopted in frequency modulation system to improve the signal to noise ratio of the transmitted audio signal. The technique involves boosting the higher frequency of audio signal before modulation. Mathematically, pre-emphasis is achieved by using a first order high pass filter. In the time domain, the pre-emphasis process can be represented by the following equation: S of pre-emphasized t is equal to S of t plus tau d of S of t dt, where S of t is the original audio signal, tau is the pre-emphasis time constant. The equation emphasizes the higher frequency component of S of t by adding a derivative term proportional to the rate of change of the signal. Now, the frequency response, the application of pre-emphasis alters the frequency response of the transmitted signal. Typically, in FM system, the frequency response without pre-emphasis tends to emphasize lower frequency due to the nature of modulation. However, the pre-emphasis boosts high frequency, thereby compensating for the natural attenuation of this high frequency during transmission. Graphically, pre-emphasis modifies the frequency response curve of the FM signal, emphasizing high frequency relative to low frequencies. This adjustment helps in maintaining a balance and clear audio signal across different frequency ranges, which is crucial for achieving high quality audio transmission. Now, with this fundamental knowledge of pre-emphasis and de-emphasis, it is time to discuss some detailed applications of this technique. The pre-emphasis find extensive applications in various real world scenario where high fidelity audio transmission is crucial. It finds its application in FM broadcasting. In commercial FM radio broadcast, pre-emphasis is a standard to improve the overall audio quality of the transmission signal. It ensures that the audio received by the listener is clear and free from noise interferences, especially in environment with varying levels of background noise. It is extensively used in telecommunication that utilizes FM modulation. It helps in enhancing voice clarity and particularly in telephonic applications where maintaining the fidelity of speech signal is essential for effective communication. In audio recording and production, pre-emphasis is sometimes used during mastering process to prepare audio tracks for distributions. By boosting the high frequency before transmission or storage, it helps in preserving the dynamic range and details of recorded audio, ensuring a more natural and balanced sound for listener. So, this is all about the applications across different domain. Now, it is time to move to the next section of this lecture, the de-emphasis process. In the context of frequency modulation communication system, the process of de-emphasis is crucial for maintaining the quality and fidelity of the transmitted audio signal. De-emphasis is a technique applied to the receiver end of an FM system to counteract the effect of pre-emphasis that were applied at the transmitter end. So, pre-emphasis and de-emphasis works together to improve the signal to noise ratio during transmission and ensures that the received audio signal closely resembles to the original signal before transmission. The primary purpose of de-emphasis is to restore the natural balance of frequency in the audio signal that was disrupted by the pre-emphasis process during transmission. High frequency components of the audio signals are amplified more than the low frequency component. This amplification is done to combat the high susceptibility of higher frequency signal to noise and thereby improving the overall signal to noise ratio of the transmitted signal. However, if the received signal were played back without any further processing, it will sound unnatural, bright and harsh due to the changes in the high frequency component. De-emphasis is applied to attenuate this boosted high frequency component, bringing them back to their original level. This process is essential for noise reduction as well as it helps in minimizing the high frequency noise that might have been picked up during transmission. By doing so, de-emphasis ensure a smoother and more natural audio output, maintaining the intended dynamic range and tonal quality of original signal. Now, let us discuss the implementation of de-emphasis. De-emphasis is typically implemented in FM receiver using a first order low pass filter. The design of this filter is complementary to pre-emphasis filter used in the transmitter side. The transfer function of the de-emphasis filter can be represented as H of f is equal to 1 upon 1 plus j 2 pi f tau, where f is the frequency, j is the imaginary term and tau is the time constant that matches the pre-emphasis time constant. The standard time constant for de-emphasis in FM broadcast is around 75 microseconds in United States and 50 microseconds in Europe. In practical term, the de-emphasis filter is usually an RC, resistor capacitor circuit designed to achieve the required time constant. For instance, to implement a 75 microsecond time constant, one could use a resistor R and a capacitor C such that their product R cross C equals to 75 microsecond. A typical combination might be a 10 kilo ohm resistor and a 7.5 nanofarad capacitor. This simple yet effective circuit attenuates the high frequency in the received signal, reversing the effect of pre-emphasis applied during transmission and thereby restoring the original signal response of the audio signal. Now, let us discuss some of the interesting historical significances related to the development of the de-emphasis technique. Dates back to the earlier days of FM broadcast. As engineers begins to understand the benefits of pre-emphasis for improved signal to noise ratio, they quickly realized the necessity of an opposing process at the receiver end to restore the audio signal natural balance. One significant milestone in this field was the standardization of de-emphasis time constant by the regulatory bodies like Federal Communication Commission FCC in United States. This standardization was crucial in ensuring consistent audio quality across different FM broadcast and receiver. Now, let us move our focus to the frequency response curve. The de-emphasis process is characterized by a frequency response curve that mirror the pre-emphasis curve. In essential, while pre-emphasis amplifies the higher frequency component of the audio signal to improve its signal to noise ratio during transmission, de-emphasis attenuates this same high frequency at the receiver to restore the signal original balance. The frequency response curve of de-emphasis filter typically decrease at a rate that matches the increase caused by the pre-emphasis filter. This ensures that the combined effect of pre-emphasis and de-emphasis is a flat frequency response, maintaining the integrity of the original audio signal. For instance, if the pre-emphasis filter boosts the frequency above a certain cutoff, say 2.1 kilohertz, by a specific amount per decade, say 6 dB per octave, the de-emphasis filter will reduce the frequency by the same amount. This complementary relationship between pre-emphasis and de-emphasis is crucial for maintaining audio fidelity and minimum noise. Now, let us have a look on the mathematical representation. Mathematically, de-emphasis can be represented as a complementary functions to pre-emphasis in the frequency domain. The transfer function of the de-emphasis filter is designed to have an inverse relationship to that of the pre-emphasis filter. If we denote the transfer function of the pre-emphasis filter as h p e of f, then the transfer function of the de-emphasis filter h d e of f can be expressed as h d e of f is equal to 1 upon h p e of f. This inverse relationship ensures that the overall frequency response of the systems remain flat. In practical terms, if the pre-emphasis filter increases the amplitude of the higher frequency component according to the specific time constant tau, the de-emphasis filter will attenuate this component by the same time constant. In the time domain, the standard time constant for de-emphasis in FM broadcast is 75 microseconds in United States and 50 microseconds in Europe. The de-emphasis filter is typically implemented using a RC resistor capacitor circuit, where the product of the resistor and the capacitor equal to the desired time constant. For a 75 microsecond de-emphasis filter, a common configuration might involve a resistor with 10 kilo ohms and a capacitor with 7.5 nanofarad. The transfer function of such RC circuit can be expressed as h de-emphasis of f is equal to 1 upon 1 plus 2 pi f tau, where f is the frequency, j is the imaginary term, tau is the time constant. In summary, the implementation of de-emphasis involves designing low pass filter with a frequency response that compensate the pre-emphasis filter used during transmission. This complementary relationship is essential for maintaining the original audio quality and minimizing the noise in FM communication system. By understanding the mathematical basics and practical designs of de-emphasis filter, engineers can ensure high fidelity audio reproduction in FM receivers, preserving the integrity of the transmitted signal for the end user. The advantages and limitations of pre-emphasis and de-emphasis technique. The pre-emphasis and the de-emphasis techniques offer several advantages in the realm of frequency modulation communication. The primary advantages is the significant improvement in signal to noise ratio for high frequency signal. Pre-emphasis amplifies the high frequency components of the audio signal before transmission, thereby boosting this component above the noise flow. This enhancement ensures the high frequency sound, which are typically more susceptible to noise, are transmitted with a greater fidelity and clarity. Consequently, the listeners receives a clear and more accurate audio signal, which is particularly beneficial for music and speech broadcast. Another advantage is in noise reduction during transmission. By emphasizing high frequency at the transmitter end and subsequently de-emphasizing them at the receiver end, the overall impact of noise introduced during the transmission is minimized. This process effectively reduces the received noise in the received signal, resulting in a clear and more enjoyable audio for the listeners. Additionally, the use of pre-emphasis and the de-emphasis helps in maintaining the integrity of the transmitted signal, ensuring that the audio quality remains consistent over varying transmissions, distance and condition. However, there are some limitations associated with this technique. One significant drawback is the added complexity in the transmitter and the receiver design. Implementing pre-emphasis and de-emphasis required additional circuitry such as high pass at the transmitter end and a low pass filter at the receiver end. This added complexity can increase the cost and designing efforts required for FM broadcast equipment. Moreover, the process is frequency dependent, means that the pre-emphasis and the de-emphasis filter must be precisely matched to ensure proper signal restoration. Any mismatch in this filter can lead to distortion and degradation of audio quality. Another limitation is the potential for reduced audio fidelity in the system where de-emphasis process is not correctly applied. If the de-emphasis filter do not accurately complement the pre-emphasis filter, the received signal may suffer from excessive attenuations of higher frequency, resulting in a dull or poor sound quality. Additionally, in environment with varying noise level, the fixed nature of pre-emphasis and de-emphasis filter may not be optimal for all conditions, potentially leading to the suboptimal noise reductions in certain scenario. Despite this limitation, pre-emphasis and de-emphasis techniques remain highly relevant in modern communication system, while the digital communication methods such as digital audio broadcast and internet streaming has gained popularity. Traditional FM broadcasts continue to be widely used, particularly in regions with limited digital infrastructure. The principle of pre-emphasis and de-emphasis are also applied in other communication technologies such as analog audio recording and transmission, where similar challenges related to noise and signal fidelity exist. In summary, pre-emphasis and de-emphasis technique offer significant advancement in improving the signal to noise ratio and reducing noise in FM transmission. So, let us conclude today's lecture. To conclude, pre-emphasis and de-emphasis are fundamental techniques in realm of FM broadcast and communication system. These techniques are used for enhancing signal quality, reducing noise interferences and ensuring accurate audio reproduction. The importance of the pre-emphasis and de-emphasis in FM broadcast cannot be overstated. By significantly improving the signal to noise ratio, this techniques plays a pivotal role in making the FM radio a reliable and high quality medium for audio transmission. Looking forward, the future ongoing advancements in digital signal processing and transmission technologies promises to further enhancement the effectiveness and efficiency of pre-emphasis and de-emphasis technique. DSP offers more precise and adaptable methods for implementation of this process, allowing for the dynamic adjustment based on real-time condition. Additionally, as transmission technologies continues to evolve, the integration of pre-emphasis and de-emphasis into digital broadcast standard will likely lead to even a great improvement in signal quality and noise reduction. So, in digital era, the principle behind pre-emphasis and de-emphasis remain relevant. Modern communication systems including digital radios and television as well as streaming services continue to be benefited from the foundational concepts of this technique by incorporating advanced DSP algorithm, and contemporary systems can achieve superior audio and video quality, maintaining the legacy of pre-emphasis and de-emphasis while adapting the new technological landscapes. So, in summary, the enduring and relevance and continuing evolution of pre-emphasis and de-emphasis highlight their critical role in the field of communication. As technology advances, these techniques will undoubtedly continue to be refined and integrated into a new system, ensuring that these high standards of signal quality and fidelity are maintained. So, with this, we have come to an end of today's lecture. Thank you for your attention. Before we conclude, I would like to take a moment to thank you all for your participation and attention throughout this lecture. Take care and have a great day. Thank you.